Welcome. See, after uploading the last class, I don't remember class number, where it's a long class, nearly 3 hours. I gave all standard expression for locating centroid for different shapes. I have given 3 days break. Purpose is let everybody go through it, thoroughly understand. And now, from today onwards, when I locate centroid for rectangle or a triangle or any type of triangle or trapezium or circle, semicircle, quadrant of a circle, I will not waste too much time telling that, see, it is like this, it is like this. It is explained long back during derivation ones, summary ones. Yesterday, last class, full recap given with thorough explanation. Therefore, you should go through everything and understand and make proper notes. Then everything will be clear. Now, today's class, see, now we are going to start examples. Question number 1. But today's class, no question number. This is a master question for locating centroid with all concepts and thorough explanation. Reason I will tell you. See, when you find x bar, you can either find x bar from left extreme vertical edge, see, this way. Or you can from that side, x bar this side, your choice. Or y bar, you can find this way or this way. Each and every class, we cannot do that way. Let's try first here, then get from there. One solution, that's all. But this question, this class, I am trying all the possibilities so that everything is clear. And in this question, in one of the calculation, I don't know x bar or y bar. See, I think it may take this point. It will be right. Yes, it will come negative. Maybe in one calculation, one of them will come positive, one will come negative. I will set the, I will see that it will come. Another calculation, both will come negative. Correct, if I take that, both will come negative. So all those things I will explain. You should go through each and everything in today's class very carefully, listen to everything told and make fair copy. How many times I solve, you also solve same times. See, but this sketch I am maintaining as it is. But you have to write the sketch each and every time because the origin will change. All I have to do is rub this one and ship it somewhere. But you can't do that way. You have to write one more sketch neatly, everything. Okay, now start. Question. Locate centroid for given lamina is the question. Right, all dimensions in millimeter. I won't waste time writing every time millimeter like that. Okay, then this is the lamina given. See, 60, 100, 230, 164, 50, 74. Somebody may ask, why 164? There's a reason for 164. I will tell you what is the reason. When I find x bar, y bar, when you divide by the area and when you, in the numerator, when triangles are there, 2/3, 1/3 will come. Suppose the length, one side of the triangle is 60, divided by 3 will give 20. Okay, good. Suppose it is not 60, it is 20, divided by 3 will give you, how much 20 by 3 is? 6.6667 will come. Or divide by, take 2/3, no, not 6.67, 20 by 3 is 8.3333. Why see, nowadays what happened is too much of depending on calculator. I am finding difficulty for 20 by 6. Okay, 20 by 6 is 20 by 6, 6.666667. Other will come 13 point, oh, correct actually, double, 13.3333. Then some approximation will come. It will come from next class onwards. But this question, I set the question so that how somebody will ask how you set the question. That is not for you. I set the question. See, one last side I kept pending. So I set the question so that you will get a definite answer. Any decimal. That is no recurring number. You won't get 38.41687415. Not like that. Definite answer will come because answer has to perfectly tally. That is to give you confidence. So for that purpose, one last side, I set 164. I found what area should be there so that when you divide by that area, actually total area I set for 50,000. If the total area is 50,000, Then when you divide by 5, you won't get that 0.6667 like that. And when triangles are there, I have taken care that the sides are either multiple of 3. See here, 90 here, 240 here. These all based on your mathematical capacity. But for you, question given, see, 60, 100, 230, 164, 50, 74. Somebody will say, sir, this is not given. That cannot be given. Okay, I will tell 1 minute now. I cannot give this side. If I give this side, it becomes nonsense. Or I can give the correct side. See, it comes finally 100. I can give that side, no doubt. I can give, this side is already given here, 60, 100. Then one of them is missing there. What is missing? 100. Then you have to come to this point. This dip is not given. See, something is missing. I cannot give all the sides because reason is that then it will not satisfy that actual dimension. So how to decide? Enough. See, sometimes in the question, some dimension is missing. It is a mistake of the person who set the question. Now, I will tell you how you decide. See here, this question, see, this drop is not given. Something missing here. The drop is not given. How to decide or how to decide that given question is correct? I will tell you one thing. See here. You start from here. Mark this point. See, if you can construct the sketch using given dimension, then all the sides you can find. See, I'll start from here. I'll go by 60 here, come down by 100, stop here. Then I will again come down by 100 here, go by 230 right, come down by 164, come left by 50, go up by 74. Yes, this point comes. So join these 2 points. Yes. Therefore, this drop I cannot give. Actually, I can give it as 90. It comes to 90 later. That you have to calculate. Okay, leave it now. This is the question given. Now, class. First of all, remember how many parts you have to divide. See, common sense. See, you can divide. See, correctly here, light line this way. Then, if you divide this way, then again you have to divide this. Oh, this becomes problem. What happens? Rectangle, rectangle. Then again 2 rectangles will come. So it is better not divide that way. Actually, that way only. So these 2 together, you take a rectangle. Correct? Yes. Rectangle and divide like this. So you get one rectangle here, one triangle here, one more rectangle here. Today's class sufficient. Semicircle, circle, that all will come one by one later. See, what principle I am explaining for that rectangle, triangle, etc. is not important. How to locate centroid of each component. I told principles, concepts. For concept purpose, only rectangle will do. But only rectangle, long back one question I solved. So I will go for this question. See, first, let us divide the given lamina into 3 parts. See, I am rubbing this one now and consider, let us divide lamina into 3 parts. 1 minute, this I will write later. Okay, 1 minute. 3 parts, okay. This I will write later. Okay, 1 minute. So that to make very clear, okay, leave it. Into 3 parts, see here. 1, see, I will divide, see, you can see here only. I will divide like this way, and this way. So 50 and 60, it is slightly out of scale, no problem. 1, 2, 3, see here. 1, 2, 3. Okay, then. Now you see that all dimensions are clear. Make a note here. See, in this lamina only make a note. This is given, how much? 60. This is given, 100, 100. See here. This is same point, same level. See, 100, 100. This is given, how much it is? Here, 650. This, see, this full height given, 164. That also given. Then, from here to here given. How much given here? Right here. One more sketch, 74. If this is 164, don't see that side. That is something else. Don't see that number. See, if this is 164, this is 74, then this will be, see, make a note here. This will be, you should make a note of that one. Later I won't explain. This will be 164 minus 74, that will become 90. Therefore, later, see correctly how I enter dimensions very clearly. See, 60, all in millimeter. You write somewhere. I am not wasting my time in future. Somebody will comment, he wrote numbers without writing unit. I told him that those who are studying, they should know these things. Once I told all in millimeter, every entry is in millimeter. Okay, see, 60, some scale I maintained, 60. Then, see correctly, this is 60. I want this triangle from here to here. How want to get it? See here. This is 60. Then, see, I want how much? From here up to here. How to get it? See, from 230, you subtract 50. You make a note here. See, I want this dimension. Why? That is going to be some extra distance, not triangle. See here. From here to here is 230. See, this is 230 and this is 60. So, it is 230 plus 60. That will give you from here to here. No, not required. No. I want this distance. So it is, see, this is 230, this is 50. So this is 230 minus 50, that will give you 180. See, I wrote here 180. Then, for the triangle, you require the base. See, for the full triangle, you require this base. Okay, now, see, this one. This is the triangle base. See, up to here. How to get it? See, from here up to here is 60 plus 230. 60 plus 230, you calculate that one, that will become 290. Somewhere make a note here. Okay, somewhere here make a note. This full is 290. 290. I already explained. See, 60 plus 230 is 290. From 290, you subtract, first you get 290. First you get 290, from 290, subtract 50. So this will be 290 minus 50 equal to 240. So for this rectangle 60 and for this triangle, I don't want there, so I'll project down. This, for a triangle, this side is 240, full is 290, and this thickness I wrote there. And 60, this is 50, this 180 is some distance. It is up right edge of the rectangle up to here is 180. You require it. Fill up all the gaps. So 60 should be clear, 180 should be clear, 50 should be clear. And 100 is crystal clear. 90 I have shown the calculation. Then this is 74. How? Given in the question, 74. This from this point to this point is 74. Actually, which point? Not that point. See, little. Okay. That is not a big issue. Okay, 74. 74 here. Then further. See, this side 240 I explained. Then 230 plus 60 is full is 290. 290. Then this is 50 here. Vertically, this is 164 given in the question. Right? 164 given in the question. And now from 164, see, this is 164, this is 100. So the full height from topmost edge to bottommost edge is 264. Usually, when you locate centroid, you make a practice to write the outer boundary dimension. Extreme left to extreme right. How much? Here it is 290. Top extreme to bottom extreme is 264. You make all these notes. Those who want, you write a rough sketch here, practice and get it. Of course, this is high school level mathematics. Okay, now this is ready. Now I will do one thing now. See, now I will make a note here. One small note. See, here only I will write. We want to, this sketch I am going to remove later. See, this sketch I am going to remove. I will write it later. We want to locate centroid G, means we want X bar and Y bar. Usual practice, most popular is take X to right side, Y upward, and bottom left extreme corner You take origin. So what you will do is, we will take, we will consider, after all this one, you write here. So one statement required, this I will remove. This I will remove now. This sketch I think not required now. I can remove this one. So one statement you write. First, divide into parts. That is already clear. 3 parts are clear. Then write. What I removed here, you write here. Then let us consider. Green color. Reference axis. Access to OX, and I use always small letter because capital XX, capital YY, I want for centroidal. This is my choice. OX and OY for locating centroid, for finding distance of centroid, distances of centroid. Red color required, okay, leave it now. Of centroid, okay. Well, red color. Centroid means full red color. Of centroid. Where is red color here? Here. Distance of centroid G for entire given lamina. I will not waste time now. Given lamina. OX, OY. Where? As shown in figure. As shown in next sketch. That is the most important sketch, which is for reference here. Bottommost point, this one. Extreme left here. This is my O. See, this is by taking point O here. This is your X. So your X is to right side, Y is to upward. Now remember, when you want X distance, it is this way, but X measured from OY. Thousands of times I told. And X is measured from O to right side, but measured from OY axis. Y we are going to take upward direction, measured from O upward, but measured from OX axis. Okay, over. This is one solution. So this is main solution now. Now, complete I will remove and prepare a table here and explain centroidal calculation. See, I don't want to waste time. Therefore, I will write the table, etc. and start. Start now. See, space problem is there. Everything I want in a single stretch I want. So it's smaller I written. You should see in the laptop. Don't actually mobile also I saw it. It is quite visible in mobile also. But laptop is much better. Or TV screen. You do one thing. Don't write such small sketches. Write a big sketch and maintain some scale so that everything is crystal clear. Okay, start now. This don't see here. See, we are here. Don't see this side now. Okay, now statement, whenever there is no space, I will give statement in the class. I will dictate, you should write. Okay, I explained everything. Origin O you will take here, X this side, Y this side. If I am not told, you write now. If I am not told earlier, I don't remember, you write. See, consider, next time I won't tell. Consider reference axis OX and OY as shown. You continue to get X bar and Y bar. You can continue to get X bar and Y bar. Okay. OX here, OY here. Remember, you can further make a note. OX is the axis. From OX, you are finding Y bar. From OY, you are finding X bar. This is all I told. And see, make one more note here. Your X is from O, your X is to right side. See, right side. And Y is upward. Very important. So, this is sign convention. We are taken here. X right side positive, Y upward positive. Start. figure number 1. See, this I will explain part number or figure number 1, 2, 3. Area 60 by 100. This will never change now. 6000. All in millimeter square. Figure number 2. Half into this full triangle. Half into 240 into 90. I got 10,800 mm square. Figure number 3. 50 into 164. 8,200. Total area A1 plus A2 plus A3 is 25,000, not 50,000, 25,000. That also will do. 25,000, 20,000, 50,000, 32,000 or 64,000, 80,000, 1 lakh, 1,25,000. If you divide, you won't get the recurring numbers. Okay, over. That you don't bother. Over. Now, very important, you can make one more note. See, we have x bar to right side and y bar, this already I told you, I won't repeat again and again, how many times I have to tell. Y bar, we take up, see, B, okay, up, B, distances of centroid G from y bar, see, I told x bar from, I told x bar from OY axis, y bar from OX axis respectively. Then we know that x bar equal to, from OY, A1 x1, A2 x2, A3 x3 by total area A1 plus A2 plus A3, y bar equal to, up we are taking A1 y1, A2 y2, A3 y3 by total area. This will give formula. If you want, you can write once again. A1, A2, A3 are area of each component. You see, if you want, x1, x2, x3 are, one place you write, distances of the x distances, that is horizontal distances of centroid of components 1, 2, 3 respectively, all from OY axis. Then y is y1, y2, y3 are distances of centroid of components from OX axis, all x to right side, all y to upward from this way. Okay, start. Now very clearly, see here. Now I won't explain, waste too much of time. See, centroid G1 exact center, G3 center here. See, this is 74, this is 164. Half of 164 is 82. 82 means it is slightly above 74. See, slightly above 74. Okay, that much you can make out. And this triangle, if you want, see, for this triangle, I won't tell again and again now, divide into 3 parts. Divide into 3 parts. Centroid is here. 1 by 3, 2 by 3, 1 by 3, 2 by 3. 1 by 3 and 2 by 3 of 240, 1 by 3 and 2 by 3 of 90. This is explained many times so far. If you don't follow now, don't study from me. You study from a better person. Okay, start. X1, see, from this way, here to this centroid, 60 by 2, 30, all millimeter. X2, see, directly, I written here, see, actually this you need not write. I wrote only for this question. See, 2/3 of 240, 160. X3, see, this centroid, 240 plus another half of 50. 240 plus half of 50 over. Y1 here. 164 or 74 plus 90, then plus another half of 100. Oh, here, half 100. Y2. From here, first you have to come here. The 74 from here up to here plus another 2 by 3 of 90. 134. Y3 directly 164 by 2. Substituting x bar, y bar. Next time, this substitution I am not doing. I will put a signature. Why? You should do it. X bar, see, A1 x1, A2 x2, A3 x3 divided by total area. You get 163.244. Y bar, A1 y1, A2 y2, A3 y3 by total area 136.144. Okay, once everything is over, you make a note. Continue question. not over. See, I put a red dot here. Come here, not come here. Here, from there you come here. Therefore, centroid G for the entire lamina, write the lamina once again, where individual dimensions not required, boundary required. This is 290, this is 264, boundary. For the entire lamina, centroid G will be as shown here. See correctly. From OY axis, X bar came 163.24. See here. 163.24 means, see, this is 240. This triangle is 240. 240, 2/3 is 160. Slightly more than the centroid of the triangle. See, slightly after this point. But that point is not required. So, 163.24 from here. Now, this is your X bar. Suppose you want from that side, what you do? From 290, you subtract 163.24. You should write it. In the class, you write a note. From 290 minus 163.24 will give you 126.76. I made a note there. It's correct, 126.76. From here, it will be 126.76. If you want round off, means calculated value. Y bar from here, we got how much? 136.144. Here, this is 164 by 2 is 83, further above. Up to this centroid is 164 minus 30. 164 minus 30 is 134. We got 136.144, slightly above centroid of triangle. Slightly above centroid. Okay, you mark here. This is centroid G for the entire lamina. This is your Y bar, 137.4. Now, if you want from that side, from 264, subtract it. 264, subtract 136.144. You will get 127.856. Correct. I noted down. 127. Don't write Y bar, it's other distance. 127.856. Remember, it is a calculated value. Okay. Make a note. This will complete location of centroid. I'll just check the camera once. Okay, no checking required, because now I am going to alternate solution. Now do one thing. This is our question is over, but still I will continue little more, much more, so that all different possibility we will study in this question. That's why it is master question. Okay. I will prepare it. Now see correctly how I explain. Don't see anything now. Right here. All dimensions. Somewhere I write this actually. I am rubbing it now. Okay, centroid meter. All dimensions in millimeter. Okay. Okay, now. Right. Alternate solution. Alternate solution. Fully you right. Okay. Division is same. That 1, 2, 3 part remains same. Consider reference axis OX, OY as shown. See here. As shown here. Now make a note. Usually bottom left corner is the most popular, so that X goes to right side, Y goes to up. Or sometimes people also prefer top right corner. See, top level right extreme corner O. Now what I will do is, see here. Now what I you should write here. Now see, you write here. Take origin. You make a note here. Take origin. Last time you write at the bottom left extreme corner, bottommost left extreme corner. Now write topmost right extreme corner. From there, let X be this way. See, now your X is like this and Y is this way. Make a note. So, as shown means, see, X this way and Y this way. This is very, very important. This is O. Select there. Okay, then let X bar to left side and Y bar down be distance of centroid G from same statement here. X bar to left side, Y bar to down. Now see, your OY, X from OY will be from O, see here, the other problem. This is I should The multiple color means this is a problem always. Okay. What to do? See, now from O, X is this way. See, from O, and from O, your Y is this way. Okay, start. Figure 1, figure 2, figure 3, same part number. Area remains same. Don't waste time, but you should write once again. Start now. X. G is here. 50 plus 180 plus another half of 60. 50 plus 180 plus half of 60, 260. You can write here. Or you can do one thing. From 290, you subtract half of 60. You make a note. Or in the bracket. From 290, subtract half of 60. Okay. 2. Centroid here. 50 plus from here, see, from here up to here is 1/3 of 240. 50 plus 1/3 of 240. I wrote here. X3. Oh, center directly half of 50 over. Y distances from top. Figure 1, 100 by 2. Okay. Figure 2, 100 plus this distance. See, from here to here is 100 plus 1/3 of 90. Figure 3, 100 plus half of 164. Okay, 182 came. Now substitute. X bar to left side equal to. Now you should substitute. You see, those who are learning from me, if you are too lazy to substitute, I am helpless. A1 x1, A2 x2, A3 x3, substitute. There is no space here. A1 x1, A2 x2, A3 x3 divided by total area will give X bar 126.76 millimeter, and not bother to calculate because I know the answer. Okay, then Y bar from top will come A1 y1, A2 y2, A3 y3. You substitute. If you want to learn, you substitute. Otherwise, be lazy and pay penalty later. Y3, it will come 127.856. Right. Therefore, from there, come here. Centroid G for the entire lamina will be as shown here. See now. Now you should do one thing now. When you put this sketch now, you should change it. See, I am changing. You should change it. One more sketch you require. See, now this is light line. Oh, this is some disturbance here. Okay, 1 minute. Disturbance here. Okay. See. This is your origin. Which one? Oh, color problem is too much. That color gets mixed up with this color gets mixed up with that color. Which color, where I get confusion now. Red color is here, green is here. Okay. See, your light line. Don't see other things. This is your origin O. From O, you have taken X this way. See, X this way. From O, see here. O, you have taken Y this way. See, from this point, O, X bar to left side is 126.76. So, this time, this is not round number, see. This is calculated value. This is your X bar equal to. This value from 290, you subtract calculated value. Whereas here, this is your Y bar, see. Now, this is not round number, no. This is your Y bar. How much from top? 127.856. Space problem. Okay, manage it. This is calculated. How you got? From 264, subtract it, you get this distance. So, centroid will remain same. Okay, now I will go to alternate solution. Further, see, alternate over. I will further go alternate. Some tricky things are there for understanding purpose. Very, very critical. I will give a note for you. Now, don't see that side. Go for one more alternative solution. alternate solution. See, you make a note. Already I told you, when you locate origin or when you measure x and y, it is better to take reference axis either left extreme edge vertical or right extreme edge vertical, or top extreme edge or bottom extreme edge, or take bottom left extreme edge. See, bottom left extreme edge, so that x goes this way, y goes this way. No negative will come. Or top extreme edge. So x goes this way, y goes this way. No negative. Negative means problem. So it's advisable always to locate centroid considering extreme edges as reference, either for x bar, either left vertical extreme edge or right vertical extreme edge. For y bar, how many times I told, bottom horizontal, bottom is horizontal only, bottom extreme edge or top extreme edge, right here. But suppose in the question, see, by chance in the question given, see the shape, this way, then this way given, okay. Suppose, imagine, in the question someone told, locate centroid for the given lamina with respect to OX and OY. Suppose he gives here, see, he will tell O here, then he will tell this is your OX, this is your OY. If he tells that way, still you can do one thing. You can take extreme edge reference and then subtract these distances and get it. But still, somebody will get upset. I told you, do the calculation, or maybe in interview, he will tell, no, you take reference of OX and OY only. Okay, in that case, what to do is make a note here. See, this point O, in the question paper given, this is Y. See, Y from O is up. X from O is right side. So see, from here, X right side, Y up, origin here. Then, what to do? See correctly. Actually, not advisable, start. Write a neat sketch here. O, this sketch will remain same. Start. Now see, X bar is to right side. See, as per X, right side from O. X bar to right side from OY axis. Y bar is up from OX axis. Okay, formula remains same. I change it. X bar to right side, Y bar up, or I change table. See, A1, A2, A3 will remain same. X1, see, correct, clear. Your figure part 1 is here. See, from here, X is from O, X is right side positive, but this is coming left side. See here, left side. So you should take this distance as 60 by 2, but minus sign, minus 30. Whereas X2, see here, from here to here, how to get it? This is 2/3 of 240. See, from here to here is 2/3 of 240. Subtract 60. From here, you will get 2/3 of 240 minus 60 will come to right side only. Therefore, positive. X3, very simple. See, from here, 180 plus half of 50, 205. Y, for figure number 1, see, your Y is upward. So what? 100 by 2 plus, it is plus actually, plus 50. Figure number 2, centroid is here. See, this distance, but our Y is upward. So minus 1/3 of 90. Minus 1/3 of 90 is minus 30. And figure number 3, see, our Y is going up, but it is coming down. Minus of 164 by 2, minus 82. Substitute, see, correctly. 6,000 into minus 30, you should, now substitution, you should do it. Okay, I'll substitute here. 6,000, only this time. Only this time I'll substitute, because why? Negative is there. 6,000, bracket I'll put here, into minus 30, A1, Y1, A1, X1 plus 10,800, one more bracket, into X2 is 100 plus one more 8200 into X3 is 205. 205 divided by total area, you will get x bar plus 103.24. Y bar 6000 into 50, 6000 into 50, okay, I'll remove this one now, only for this time. 5000 into 50, okay, big bracket, into 50 plus bracket. 10,800 into y2 minus 30, minus 30, close the bracket, plus, once again, 8200 into minus 82 divided by total area, you will get to minus 27.856. Make a note here, x bar came positive, but y bar came negative. Therefore, when you put the next sketch, what you have to do? This will not come. See this answer, you will see later. Don't see this one. Your final answer I will put now. Okay, this x and y will go. Okay, little dirty became, okay, no problem. See, I never bother about that. This is 290 total. Where are here? This line, what is this line? This line is not there. Okay. Total 290. See, now our origin is here. See here. This is the origin. Origin O. From here, your x is this way. This is x. This is y. So, x bar, sorry, I forgot to change here. See, okay, someone will comment. See, people are there. I forgot to change it. It is right side. Okay. People who want to comment, telling that what does not know direction properly. Okay. X bar, from here, we took right side. You make a note here. From OY line, x bar, you took right side. And answer came positive. Means correct. It is to right side of, from here, this is your x bar. X bar equal to 103.24. 3.24 millimeter. Millimeter not required. And y bar, from this OX line, see, from OX line, your y bar, y you are taking upward. Make a note here. You took y upward, but negative sign came. So, from OX axis, y bar is not upward, it is down. So, therefore, see here, see from OX axis, 264, I'll remove now. See, this is down. Once you put down, now you should not write minus sign. So, this is your y bar, sign removed, equal to how much? 27.856. This is centroid. Now see, correctly observe. This is 103.24. This is 60. That will give from here 163.24. That is same as your earlier answer. Just because you change the reference, centroid position will not change. And this is 100. This is 27.856. So from the top extreme, it will be 127.856. That was the last time answer. 127.856. Where is it? Somewhere I made a note. This is for alternate solution. Okay, now I will do one thing. I will give one more alternate solution. Just to understand. See here. Make last alternate solution. Last alternate. Just to understand. See, suppose in the question, they told you to take reference, see, instead of here, they told to take this point reference. This point reference. X bar, Y bar, they can tell anything. And this time, remember, they again told X this side because I want negative both. This is OX axis, OX. This is OY. They told this way. That is, they're telling you, with respect to this point, with Y, again, see, X they want right side only, but origin they want here. Suppose they want. If they want, if I put that point, Y, no, if I put that point, Y bar will come positive, correct? No, not that point. I'll do one thing now. I'll tell one, no, that point means your Y bar, okay, no problem. Your X bar will come negative, but Y bar will come positive. Okay, no problem. It will happen. Some alternative solution, what to do. Suppose they give this way. See, what to do then? Remove this one. This will not change. Remove this one. Okay, now, which point origin? This point, see. This point origin. G3 is slightly above I told. G3 is slightly above I told earlier. Suppose they want this way, see. This way X. That is, they want this junction. This way Y they want. Okay. In that case, see here, origin here. Okay. That is here. Then again, X bar is right side, Y bar is up only. That will not change. Everything will remain same. But any changes are there? This, don't see this one. Don't see this answer. Area, okay, area remains same. A1, A2, A3. X distance, you know. Now X, Y all will change now, see. Correctly observe. Start. Figure number 1 is here. Your OY is here. See, this is your, see, I marked X here. Where is I marked X here? X is to right side, see here. X is to right side, but this is here. So this is 180 plus 60 by 2, but it is to left side. So what you have to do? Minus of Y minus, see, first you find distance here. From here, see, from here, from this axis, come here. This distance is 180 plus half of 60. So 180 plus half of 60. 180 plus 60 by 2. But since that G1 is to left of OY, you take outside minus equal to, it will come minus, I have to calculate. 180 plus 30. Calculate is not on. 180 plus 30 is minus 210. Okay, this is minus 210. X2 from here to here. See, our X is to right side, this is to left side. So it is here 1 by 3 of 240, but negative sign. Minus of 1 by 3 of 240 is minus 160. X3 is this centroid from here, right side only, so plus 50 by 2. Plus 50 by 2 is plus 25. Y, see here, this centroid there. This G1 is above. How much? From here now. Now we want Y from here, see. Here, 90 plus half of 100, positive. So, no problem. 90 plus 100 by 2. 90 plus 100 by 2 is 140. Figure 2. From here to here, again upper side, 2/3 of 90, positive. 2/3 of 90 is 60, positive. But Y3, oh, that also positive only? Yes, see. Y3, fortunately, is slightly above. How much? See, this is 164. From here to here, up to, or you can do one thing. This is 164. So from here to here is, see, from here to here is 164 by 2. See, this is 164 by 2. This is 90. So from 90 subtract 164 by 2. 90, that much common sense required. Positive only, why above? 90 minus 164 by 2. 90 minus 164 divided by 2 is 8 plus 8. Now we use substitute. A1 x1, A2 x2, A3 x3, and A1, whatever is the y1 there, with minus means minus, plus means plus. A2 y2, A3 y3. Your x bar, y bar will come. Surely I will tell you, from right side we got how much? 126.76 you got. That one. Subtract 50. 50. It will come minus 76.76. I have not calculated. It has to come. If everything is correct, if my principle is correct, it has to come minus 76 point, what is that one? 76.76. 76.76. 0.76. And y bar has to come from here actually, from topmost edge or from bottom edge. Y bar, how much you got earlier? First time I got 136.144, but you are already down by how much? 74. Okay, you don't worry. You calculate. You don't do all these things. I got 136.144 earlier. 36.144 subtract 74. This is my personal calculation. Plus 62.144 will come. Okay, now I'll check the answer. See, for your satisfaction, 6,000 into minus 210 plus 10,800 into minus 160 plus 8200 into 25 divided by 25,000 minus 111.82. Something wrong. Anisha. There is something wrong. See, I can make out something is wrong. What is wrong? X1. This is 180 plus another 30, 210. Minus 210 is correct. X2. 1/3 of 240 is see, 1/3 of 240 is not 160, it is 80. Oh, got it. It was last time answer. 80. See, one small mistake. See what will happen. See, I got the mistake. Okay, 6,000 into minus 210 plus 10,800 into minus 80 plus 8200 into 25 divided by 25,000 minus 76. But once I tell an answer with a principle, if answer is not coming, my class will stop. I will stop teaching, I told. Minus 76. But see, when I got some other number, I did not get a panic. I saw something is wrong there, calculation. Oh, that 1/3, see, previous value. It was a previous value, I think. I don't know, some number is not changed. Okay. Minus 76.76. Y bar. 6,000. I am checking for your confidence into 140 plus 10,800 into 60 plus 8200 into 8 divided by 25,000. 31 point, what is one? 6,000 into 140. 140 correct? 140 is 90 plus 50, 140 correct. Okay. Plus 10,800 into Y2 is 2/3 of 90 is 2/3 of 90 is 60. 60 plus area is 8200 into 8. Why 8? 164 by 2 is how much? 82. 82 minus 74. 8. Yes, 8 equal to. Something went wrong in the calculator. 6,000 into minus 210 plus 10,800 into what I am doing? Why I have to calculate? 6,000 into 140 plus 10,800 into 60 plus 8200 into 8 divided by 25,000. 62.144. Yes, answer came. It will come. Therefore, now do one thing. See, I'll write here. Therefore, final sketch. Lastly, right here. Lastly, therefore, centroid for the given lamina, right here, G, will be as shown below, right here, neatly. 160, this around 60 aitu, 180, further 50 more, 164 down, okay. Somewhere here, where is the junction? Where do they want? They want this point, correct? This point they want, yes, see. This point they want, right here. This is the point they want, means how that point came first of all. I don't know how that point came. Oh, sorry, this C. Yes, okay. I was wondering how that point came. Okay, this is joining this way. Otherwise, first of all, how that point came. Okay. This point. Okay, from that point, see, this is their O. They told this is your OX. This is your OY, they told. So, see here. From OY, X bar to right side is minus 76.76. So, it is to left side. See. Therefore, your X bar is to left side, 76.76. And then Y bar, you took down how much? Very small value, 62.144. 62.144 means it will come, center of this rectangle is 80 odd, little above, see, here, y bar this way. I'll remove this one now. This is, no, which point? Y bar comes, oh sorry, that is not reference point. Oh, the sketch is wrong. See, sometime it happens. Okay. See, sometime in a hurry. Okay. This is the point. Okay. See, I was wondering. Okay. Correct. X bar is correct from here. See, this is the point. Okay. This is the point O. They told this origin. Then this is your X. This is your Y. Now correct. Okay. Such things happens when so much of writing is there. Lengthy calculation, feeling tired. This is human nature. And X bar correct here, this way. From here, left side. Y bar, from here, slightly, how much you got? 62.144 is upward. See, from here, again, color problem. From here, upward, Y bar, 62.144. That is, therefore, see, this is the centroid G, X bar here, Y bar here. Or do one thing. If this is 62.144, see here. This is how much? This is 74. Check the answer. 62.744 plus 74. 62.744 plus 74 is 136.744. Yes, that is the answer you got from here earlier. And if this is 76.76, this is 50, 76.76 plus another 50 will give you 126.76. Yes, that is the answer we got from here. Okay, see, the last two options, make a note here. One of the, see, best option is, this is O, best option. X this side, Y this way, best number one option. Or this corner, this is O, Y down, X, Y. These are the best two options. Then there is no minus sign will come. This origin, and once again, they wanted some origin here, this origin, they are to be avoided. So never do it unless situation requires. Never go for intermediate point as origin. Lastly, I will tell you, so remember, X bar you calculate from left extreme vertical edge. Y bar you calculate bottom extreme edge. Or X bar you calculate from right extreme vertical edge. And Y bar you calculate from topmost edge. So origin best is bottom left corner or top right corner. Remember this one. Practice this question correctly. Understand. From next class onwards, we will start a series of non-stop questions now. Where is your semicircle? There all, this much I will not do. Only one solution. I cannot do the 4 or 5 solutions there. Only one solution. But of course I will tell you in the class. If you take origin there, what happens? I will tell you. Okay, thank you. We'll meet in the next class.